Roughly 100 million years old, this strange spider-like creature was discovered by amateur amber hunters in Myanmar. While researchers still don't know what it is, the creature, which has been named Chimerarachne yingi, boasts a strange mix of features that we see on modern-day arachnids. It has 8 spider-like legs and fangs up front, while its rear end is dominated by silk-producing spinnerets punctuated by a long, thin tail. Some modern-day arachnids like whip scorpions, which aren't technically scorpions at all, also have long tails which act as sensory inputs. However, unlike this newly discovered species, whip scorpions also boast powerful pincers, which they use both offensively and defensively. While researchers are sure that the specimen isn't a spider, they also know that Chimerarachne is not ancestral to spiders. That's because Chimerarachne are much younger than the oldest spiders, which are known from the Carboniferous period, which lasted from 358.9 to 298.9 million years ago. Instead, the species appears to be a late survivor of an extinct group which was probably very close to the origins of spiders. This suggests that there used to be a spider-like animal with tails which lived alongside true spiders for at least 200 million years. Currently, researchers are taking their time in actually classifying this new creature because they want to be absolutely sure that it either belongs in an existing category or is the first example of an entirely new branch. These are the rare fossils of a carnivorous plant in approximately 47 million year old Baltic amber. The fossil, which is the oldest example of a carnivorous plant, was found in Russia and shows similarities to a modern day plant which traps its food on sticky leaves that act like a flypaper. The fossil leaves carry many multicellular stalked glands and unicellular hairs closely resembling those found on the leaves of Rhoridula plant, which is endemic to South Africa. The resemblance of these leaves to the leaves of extant Rhoridula is uncanny. Modern Rhoridula do not directly digest their prey. Instead, they rely on a symbiotic relationship between a species of bug which lives on the leaves without getting stuck. The bugs hunt down and eat trapped insects, and as they eat, the bugs defecate, and it is their nitrogen-rich feces that the plants absorb for sustenance. It is quite possible that the fossilized Rhoridula also relied on these insects as well, though no direct evidence of this has been found. The most interesting aspect of this discovery, however, is its location, because today Rhoridula is found only in South Africa. Therefore, its presence in Russia hints at a historic distribution that is much wider than previously thought. It had long been assumed that Rhoridula was neo-endemic to South Africa, with the family having arisen there and nowhere else. This discovery now shows Rhoridula to be a paleo-endemic, once having a much wider distribution but currently restricted to South Africa. This discovery, therefore, is an excitingly huge step in understanding of carnivorous plant evolution. A new genus and species of gecko from the early Eocene epoch was discovered in a superbly preserved condition in northwestern Russia. The fossil, which is 54 million years old, was found preserved in Baltic amber in 2004. The fossil belongs to an extinct genus of gecko known as Xantharo gecko balticus that lived in the early Eocene epoch, a period which lasted from 56 to 33.9 million years ago. The well-preserved specimen contains the front half of the lizard with partially preserved limbs, including adhesive toe pads and the projectile tongue lacking a skeleton. According to researchers, the fossil is the oldest geckonoid lizard to be represented by more than fragmentary skeletal remains. The discovery also revealed that this tiny species measured only about 20 to 22 millimeters from snout to vent and lacked movable eyelids. Its feet are similar to those found in current-era geckos, which prove that a complex adhesive system was present in geckos nearly 20 to 30 million years earlier than previously believed. This alien-looking insect with a bizarre head and long thin legs is so strange that it is not only a new species but also belongs in its own new scientific order. The 100 million years old amber fossil was discovered in Myanmar, and the insect has a number of features that just doesn't match those of any other insect species in the insect world. So discoverers have created an entirely new order called Aarinnoia for the creature. Only 2 specimens of this species exist, and both of them were found preserved in amber. The tiny wingless creature, which is called Aarinnoia burmanicus, lived alongside the dinosaurs and likely ate things like mites, worms and fungi, as it probably was omnivorous. The strangest feature of this insect was its triangular-shaped head with the vertex as the neck and alien-looking bowl-shaped eyes on the sides. The positioning of its head would have allowed the insect to turn its head to the side 180 degrees, literally looking behind itself. Insects today can turn their heads 180 degrees but up and down, not to the side like this, which is so unique. The insect also had neck glands that secreted what could have been predator-repelling chemical for protection. Here is another amber-encased fossil that was discovered in Myanmar. This one is a 99 million year old remains of a baby bird. The bird belonged to an extinct group called the Enantiornithes, which were the ancient cousins of modern birds. These extinct birds were winged and covered in feathers, but still retained certain features of their reptilian ancestors which modern birds have lost, such as teeth. The baby bird lived in the world of the late Cretaceous period, where early birds and large non-bird dinosaurs lived side by side. From snout to tail, the fossil is about 6 centimeters long. Much of the bird is hidden deep within the piece of amber, with only its claws clearly visible from the outside. The preserved body includes the head, neck, part of the right wing, both legs, and the hints of a tail, all covered with skin, scales, and lots of feathers. Among the other features visible are the patterns of colors on its feathers, the fine scales on its feet, an eyelid, and an ear opening. It also possessed some unusual bristle-like feathers that are quite different from what we see in modern-day birds, but similar to the proto-feathers known from many non-bird dinosaurs. The state of development of the bird's bones and feathers indicates that it had just hatched and probably died within weeks or even just a matter of days after hatching. Unlike most modern birds, however, which are born fairly helpless, the newborn already had a full set of flight feathers on its wings, suggesting that enantiornithine birds were ready to fly shortly after hatching. This adds to growing evidence that these animals exhibited limited parental care after birth.